All right, welcome to the site. You've just walked onto one of the biggest mega projects on the planet, and you're stepping into a massive role as an electrical QA/QC inspector. My job today is to get you totally up to speed on the Saudi Aramco electrical conduit inspection standards. We're going to treat this explainer like it's your very first day out in the field with a veteran lead inspector. And yeah, that's me. We'll be walking through the exact, literal standards, the common site errors you absolutely need to avoid, and the real-world scenarios you're going to face out there. Look, before we get too deep, I gotta ask you a serious question. Are you ready to sign your name on the line? Because when you're a site inspector, you carry an incredible amount of responsibility on your shoulders. You are literally the last line of defense between a safely energized facility and a total catastrophic failure. When you check that final box and sign your name, you're legally and ethically putting it out there that the installation meets every single strict code requirement. I'm probably going to give you some tough love today, but that's just because the stakes out here, they're incredibly high. So here's our game plan for today's explainer. We're tracking the conduit through its true life cycle. That means starting with materials and pre-installation prep, moving to above-ground installation, then digging into underground trenching and testing. After that, we'll tackle hazardous area safety protocols, and finally wrap up with final verification and sign-off.
All right, let's kick things off with Section 1, Materials and Pre-Installation Prep.
You know, a lot of rookies think the job actually starts when the conduit is up on the wall. It doesn't. Picture this. We're standing out at the receiving bay, clipboards in hand. When that delivery truck rolls up, your very first job is to verify the approved material against the material requisition, the MR, and the approved submittals. You've got to check the exact types. Are we looking at GRS, PVC-coated GRS, standard PVC, EMT, or FMC? You also need to verify the manufacturer certs and make sure that material traceability is rock solid. Let me give you a real-life scenario. I once saw a contractor try to accept a batch of GRS conduit that had this slight dent from a forklift. Now, if you don't inspect for physical damage, denting, and corrosion right then and there, that dented pipe goes in. And later, when the crew tries to pull a massive cable through it, it snags on the dent, strips the insulation, and the whole pull is ruined. You gotta catch it here. And oh, make sure you confirm they're storing it properly too, so it doesn't just sit out and degrade in the sun and sand.
Now, before a single piece of that conduit even thinks about getting installed, you must confirm the work area is actually ready. You have to verify they're working off the latest approved IFC that's issued for construction, drawings. Always confirm the conduit routing and exactly where the unistrut supports are located. Have the hazardous classifications been verified? The rule of thumb here is never, ever let a contractor start working blind.
Moving right along to Section 2, above-ground conduit installation. All right, so we're off the loading dock and out in the field now. Here's where you're going to see the stark difference between what the code demands and the sloppy, shortcut errors contractors try to pull when they're rushed. Proper installation means the conduit size and type perfectly match the drawings. We're talking straight alignment, adequate support spacing, and really clean thread engagement with couplings that are properly tightened. But what about the common errors? Well, watch out for rushed, flattened bends. The code dictates a very specific bending radius. If a guy flattens a bend just to save a few minutes, reject it immediately, period. Another massive mistake is leaving conduit entries exposed to moisture ingress. We might be in a desert environment, but moisture and condensation can absolutely still build up and destroy an entire electrical system from the inside out.
Now, keep in mind we're dealing with a massive physics problem out here on site. Temperatures swing wildly, right? Metal expands and contracts. That's exactly why expansion fittings are installed where the code requires them. But here's the catch. When a conduit expands and pulls slightly apart at a joint, it loses its electrical grounding connection. That is why bonding jumpers, which are basically just flexible wire bridges going right across those expansion joints, are absolutely critical. They maintain that electrical continuity during thermal expansion. If those jumpers are missing, sure, the structural integrity might be fine, but your electrical safety is completely 100% compromised.
Okay, time to get our boots dirty. Section 3, underground trenching and testing.
We're literally getting down into the dirt for this one. Once a contractor backfills a trench, all their mistakes are buried forever, which makes our physical checks down here super critical. You must verify those trench dimensions and the depth. You've got to check the conduit separation, the spacing, and the slope. If the spec calls for concrete encasement, verify it's there. And listen, here's a major one. You have to inspect the warning tape installation. Why does a piece of tape matter so much? Because if a contractor forgets to lay that brightly colored warning tape above the conduit, 5 years from now, an excavator operator might come out to dig a new trench, have no idea there's a live power feed under there, and cause a fatal accident. Finally, verify the backfilling material and compaction so the ground doesn't just cave in a month from now.
And all of this leads up to the absolute holy grail of underground checks, the mandrel test. First, you check your slope and routing. Then, the contractor executes the mandrel test, which basically means pulling a solid cylinder, called a mandrel, all the way through the entire length of that underground conduit. As an inspector, this is a strict witness point for you. You must physically stand there and watch that thing pop out the other side. Doing this confirms there are no internal blockages, no collapsed walls, and no sneaky concrete seepage inside the pipe. It's simple. Only after that mandrel passes all the way through can you authorize the backfilling operations.
Let's shift gears and really turn up the heat. Section 4. Hazardous Area Safety Protocols.
We are radically raising the stakes right now as our walkthrough enters classified areas. In these zones, a single tiny spark can literally cause a catastrophic explosion. You have to be hypervigilant here. The standard requires strictly approved explosion-proof conduit fittings. So you're looking for specialized components, specifically sealing fittings, and the sealing compound that actually goes inside them. Keep in mind, these aren't just there to keep the dust out. They are highly engineered to prevent a spark from inside the electrical system from escaping and igniting the surrounding hazardous atmosphere.
I'm going to give it to you straight here from one veteran inspector to another. Missing a seal orientation or forgetting to verify a compound pour, that's not just a ding on a piece of paper or a failed inspection. That is a deadly hazard. You absolutely must check the seal-in fittings location and their orientation. You must physically verify that the sealing compound was installed. Explosive gases can travel through hollow conduits like a high-speed highway. If a fire breaks out in one zone, these poured seals are the only thing stopping those explosive gases from shooting straight into the control room. Confirm those conduit seals are properly identified, poured correctly, and heavily documented.
Which brings us to the finish line. Section 5. Final verification and sign-off.
So we're bringing the whole shebang together right before the system gets energized. This is where you walk through what I like to call the invisible safety net. See, a system can look totally beautiful on the outside, but still be incredibly deadly on the inside if it isn't grounded properly. You must verify the electrical continuity of all metallic conduit systems. Check every single bonding and grounding connection. Confirm that grounding bushings are installed exactly where the code requires them, and verify that grounding conductor installation. All of this guarantees that if a live wire accidentally touches the inside of that metal conduit, the fault current actually has a safe, fast path to the ground, tripping the breaker instead of electrocuting the next operator who happens to touch it. Now take a good hard look at this inspection and test plan, or ITP. This document dictates exactly where you physically need to be. See those W's? That stands for witness. You cannot just sit in the trailer and review paperwork for these. You must be physically present out in the field to witness the material receiving, the underground trench before backfilling, the hazardous area seal installation, and of course that mandrel test we talked about. And see that last one, the final conduit system inspection? That's usually a hold point, meaning work absolutely 100% stops until you give them the green light.
All right, here is your ultimate step-by-step checklist for that final system verification before you put your pen to paper. 1. Is the conduit system fully complete and mechanically secure? 2. Are all the openings closed off and protected so that blowing sand doesn't get inside? 3. Are all the seals installed and actually poured where they're required? 4. Are all the supports and identifications totally finished? And 5, maybe the biggest one, does the actual physical as-built installation exactly match the approved drawings? If you can answer yes to every single one of those, then the system is finally ready for cable pulling and energization.
So I'm going to leave you with this one final thought as you grab your hard hat and head out to the site. Let's say the system is continuous, the seals are poured, the paperwork is totally signed. But did you catch everything? Being an inspector isn't just about going through the motions and ticking boxes. It's about constant, relentless vigilance. It's about refusing to compromise